very much to my chairs for this session for hosting. I'm going to be presenting today a study of the optical properties of particulate matter from biomass combustion experiments in Malawi and the particle's potential health consequences in the human respiratory system. This is work I've been undertaking in the last 3 to 4 years in collaboration with the University of Strathclyde and the Chicken Health Initiative, which is based in Malawi. I'd like to say thank you to Fiona Sutherland for providing the filters for this experiment. Okay, so a little bit about me before we start. I'm a geoenvironmental engineer with Socotec UK Limited, where I specialise in environmental chemistry and contaminated land. I've just submitted my thesis actually in the University of Strathclyde, where this research forms about 1.5 chapters, having undertaken a master's and undergrad in Exeter and Cardiff universities respectively. So what is environmental forensic microscopy? Well, it's essentially quite traditional methods of optical microscopy with a focus on the initial identification of particles under the microscopes. That's using things like plain light, ultraviolet, what it looks like if you shine a light on it, so that's reflective light, and also putting polarizers like sunglasses over the particles and trying to identify what sort of shape, colors, diagnostic features as well, like does the sample change color, all those kind of things are really important. What makes this analysis really quite appealing, as it's quite unlike all of the sophisticated methods like SEM or Raman microscopy, is it's a very low cost of analysis. So most of my work used a professional grade microscope, the Nikon Eclipse, but actually very similar findings you could get with sort of citizen science grade microscopes. So this my home microscope was a Tokyo microscope from the 1980s, and by using some gooseneck lamps and a UV gooseneck lamp, you could actually replicate very similar findings. Here on the left is actually an asbestos particle within some sand at a local river. And that just shows how well these low-cost microscopes can actually perform, and you can actually get really good results from that. So I guess really the big questions, though, where, when, how, what, and why of the project. So where was this analysis taking place? Well, it was essentially using looking at fine particulate matter, so finer than 10 microns, that's a sixth of the width of the human hair, within 1 metre of cooking apparatus in Katunga village, Malawi. That's roughly near the Mozambique border, if you know that part of the world. When this analysis originally took place in January 2017, that's when the particles were captured, but over the following 2 years there was further analysis done on the samples and the filters. How? Well, we used a personal sampling device. That's essentially a small pump, 2 litres a minute, where particle matter from the outside gets sucked through a laser light, which has got a sensor on one side and an emitter on the other, and depending on how much of the laser gets through depends on how much concentration that is read by the device. And that particulate fortunately gets deposited onto a nice little filter which can be used for gravimetric analysis, and in this case optical microscopy. So what were we doing here? We were identifying air pollutants on these filters, looking at what potential health effects they might have based on the initial chemistry, and what effects these may have on the human respiratory system if inhaled. Why this particular part of the world? Well, we were approached by the Katunga Health Initiative, where there's essentially very large problems with respiratory health, and ocular health in that part of the world, and it's felt that cook smoke might have something to do with it, and I think probably is. So I'll get into that. There we go. So this is a lady cooking at the first position. You can see here there's a big box over here with the micropen inside. Everybody was cooking boiled vegetables and also like a porridge, like bread made with cornstarch, which is quite interesting. The local the local sources of firewood was basically scavenged wood from whatever sources they could get their hands on, whether that's sort of local shrubbery. Some of it still had its leaves on, so it was quite wet stuff. You had local logging, but that stuff was expensive. Mostly whatever they could find and scavenge up was what they were burning here. That was substantially less than the 11,000 on the last sample. So look under the microscope, you can see it's very, very different in character. On this filter, which is zoomed out, you can see light grey, that's unused filter, a white band in the middle, which is some or where it's been worn, and then you can see these dark areas, and that's probably due to very fine carbon particles captured. You can see a little tiny particle of steel, probably of a highly reflective metal at the very least. Pardon me. B and C is our food particles with a shiny sort of peacock effect on the outside. D is probably like a quartz particle, probably picked up from the ground nearby, probably blown into the hut or possibly come off the hut walls, that sort of thing. E is a little tiny bead of charcoal. Again, none of these things are particularly concerning. However, F was slightly concerning. That was a smudge-like pattern and a plane light. Now, the smudge-like pattern is probably due to little tiny particles of carbon, much like the dark staining on the main filter. However, these particles, whilst comprised of carbon, tend to have an outer coating of polyaromatic hydrocarbons, sort of your benzenes and that sort of nasty stuff you don't really want to inhale. Sample 3 and 4 were quite similar to sample 1, although their locations were a little bit different. Sample 3 was under a nice veranda, and sample 4 was just outside in a communal area. The concentrations of particulate matter were considerably less, but that's probably due to it being less well constrained by the outside environment. So under the veranda it came to about 600, and outside it came to about 900. That's possibly due to the wind blowing against the structure, whereas under the veranda outside rather than the veranda, which was a little bit more windy that day. So under the microscope we had, albeit very colourful particles, slides. They were very similar in nature. We again had nice starch particles. We had these nice long line particles, which were very brightly coloured, calcium oxalate, and we had sort of purplish and light blue irregular masses, which we consider are calcium oxides. Oops, sorry. So, what are the health effects of these identified particles? Well, we had calcium oxalate phytoliths. Now, these are quite concerning as they're very, very thin. They're very small. All of the particles were less than 10 microns, but these were about 2 microns, which means that these particles can get into the very finest structures of the lungs, where most of the damage can actually get done. Now, these very thin particles look slightly like asbestos. Now, they're not asbestos. There's no reason why there would be asbestos there. But given their shape, there is a possibility that they could cause very similar effects within the lungs, possibly irritating the very finest structures. We know in plants that phytoliths, if eaten, do cause quite nasty oral inflammation, swelling. There's even been reported deaths in wildlife from these causes due to swelling of the throat and the swelling of the tongue, unfortunately causing choking. So that is something which is quite a concern from these particles, and that could explain at least some of the reason why there was such terrible respiratory effects and ocular effects in local villages. Essentially, these cactus spines could coat could cause damage at least to lung structures and the eyes. Cornstarch particles, well, these weren't particularly concerning. I'm sure a lot of you do a lot of cooking at home, and that's quite common everywhere. It can complicate lung disease. You can get things like Baker's asthma, which is a type of asthma caused by the inhalation of starch-like particles. However, that's not particularly common. It is known, cornstarches and starches are known to cause or at least contribute to a disease known as hat lung, and that's essentially due to stone wearing and the inhalation of flour while grinding, but that's more likely to be due to the actual preparation of the meal than at the cooking stage. Calcium oxides, these aren't particularly high-risk particles. In fact, it was thought for a long time that the inhalation of calcium oxides, like limestone, are unlikely to cause any long-term respiratory disease, although that view is changing in the long term, especially with the discovery of talcosis from people who use excess talc in the bedroom. That is becoming a sort of underlying health complaint in some parts of the world. And finally, we have black carbon, which was found in the charcoal burners, unlike the others which were found in the wood burners. So these black carbon particles, again, are tied to many health concerns, and that's mainly due to the PAH, the polyaromatic hydrocarbon coating, along the outer edges of these particles. These are known to cause a wide range of cardiological, neurological, and respiratory morbidity and mortality problems.